morning, friends. I am G K ThamilSelvan, Associate Professor, Department of Mechanical Engineering, State Institute of Technology. Today we are going to see the various mechanical properties of materials. Normally, mechanical properties describe how materials respond to external forces such as stress, strain, and deformation. These properties are critical in engineering and design to ensure materials perform as expected under specific conditions. Below are detailed explanation of various mechanical properties along with example. First one is the strength. Strength is the ability of a material to withstand the applied force without deformation. Each material has its own property of resistance force, with which the material offer resisting force against deformation. It is called strength of a material. It is categorized as tensile strength, compressive strength, and shear strength. Tensile strength is nothing but resistance to pulling forces. Example, steel cables and bridges. Compressive strength is nothing but the resistance to squeezing forces. Example, concrete pillars. Shear strength is the resistance to sliding forces. Example, riveted joints. The figure shows the explanation for the tensile strength, compressive strength, and shear strength. Hardness is nothing but the material's resistance to deformation, scratching, or indentation. Example is the diamond is one of the hardest material used in cutting tool. The figure shows the hardness testing machine applying force on a metal surface. So the material's resistance to deformation, scratch, or indentation is called hardness. Ductility is the ability of a material to be stretched into a wire form without breaking. Example is the copper wires in electrical circuits. The figure shows the blacksmith stretching heated metal into a thin wire. Brittleness. Brittle materials always break without significant deformation when subject to stress. Example, glass shattering when heat. The figure shows this shattering effect, shattered of a ceramic plate. Next one is the toughness. Toughness is the ability of a material to absorb energy and deform plastically before breaking. Helmets made from polycarbonate absorb high impact forces. The figure shows the visible impact of a motorcycle helmet. Over it, impact marks after a crash. Elasticity is the ability of a material to return to its original shape after deformation. Example is the rubber band. When a rubber band is stretched to a particular limit, that is the elastic limit, and when the external force is removed, it will come back to its initial shape and dimension without deformation. So it return back to its initial condition. This effect is shown in the figure. Next one is the plasticity. Refers to the ability of a material to undergo permanent deformation without breaking. Example, clay molded into different shapes. Figure shows the blacksmith shaping hard metal on an anvil. The material permanently changed to other dimension. The original dimension is transformed to other dimension. It's called plasticity. Fatigue strength is the ability of a material to withstand cyclic loads over time without failure. Example, aircraft wings experiencing repeated stress during flight. The figure shows a close-up of a fatigued metal part of an aircraft wing with visible cracks. Next one is the creep. Creep is the slow and continuous deformation of a material under constant stress over time. Example, turbine blades in jet engines operating at high temperature. The figure shows the sacking power line due to prolonged exposure to heat and weight. There are other mechanical properties, that is stiffness, impact strength, malleability, like that. Stiffness is nothing but the resistance of a material to deformation under stress. Example, diamond is extremely stiff while rubber is not. Impact strength is the ability of a material to resist sudden high force impact. Safety helmet is an example for this. Malleability is the ability of a material to deform under compressive stress. It is rolled into sheets. Example, cold leaf. Next property is resilience. Resilience is the ability of a material to absorb energy elastically and return to its original shape. Example is spring materials. The load is removed, the material come back to its shape. That deformation is absorbed in the material itself. Next is the Poisson's ratio. Poisson's ratio is the ratio of the lateral strain to linear strain. Linear strain, you all know, when the load is applied on a material axially, the material length linear dimension, the length is increased. There is an increase in the length. Then the linear strain is nothing but change in length, increase in length to original length. But at the same time, in the opposite direction, lateral dimension, that is diameter and breadth, there is a decrease in dimension. Therefore, that is called lateral strain. Lateral strain is nothing but decrease in diameter to original diameter, or decrease in breadth to original breadth. So the ratio of these two, that is the lateral strain to linear strain, is called Poisson's ratio. Rubber has a high Poisson's ratio of 0.5. Okay. Thank you, friends, for patience watching. Thank you once again.